In this video, I'm going to derive a 61 move single dedge flip algorithm for this move set. As I mentioned in the introductory video, the move optimal is 27 moves, so 61 is more than double. So it's not great. This can be improved, possibly. I'm not sure. It might sacrifice understandability, but surely it can be improved. But this was just a quick way of how I initially thought to handle this type of 2-cycle parity algorithm. Basically what I did was I found this move sequence here, and as I was doing the moves, I looked at the cycles for each of the pieces to see if I could repeat this in the fewest number of repeats to leave, let's say, I don't know. Let's take a look here. This is a 2-cycle, which is very desirable. This is wing edges in this case. It depends on how many pieces are scrambled in piece types. These parentheses and cube twister will tell you, but for this case it's first wing edges and then X centers. But this is a 2-cycle, 1, 2, 3, 4, 5. That's a 5-cycle. So if I repeat the sequence 5 times, I'm going to end up with a 2-cycle of wing edges. That's good. If I have any other big cycles and they're all equal to 5, then that would be ideal, and it is. 1, 2, 3, 4, 5. That's the third one right there. And then 1, 2, 3, 4, 5. And then I'm left with a 2-cycle here and a 2-cycle there. So let me just go ahead and play this real quick. The idea is when you're doing moves, you want to reuse the portions of the cube that you previously sliced through so that you don't break up too many pieces, because then the more pieces you break up, generally it's going to require more repeats, and you don't want that. And that's it. If I repeat this 5 times, then I have this right here. This sort of looks like a wide turn based 2-cycle parity algorithm seed, but it's 40 moves though. That's where the bulk of the moves come from, is this. And since this is a 2-cycle and a 2-2-cycle, I can conjugate this to be a single dedge flip, and other 2-cycle cases as well. These are the setup moves that I used for this. I can at least walk you through it. So we begin. I need to break up these blocks somehow. But if we just go ahead and try to do R2 to break them up. Success. Next, I'm going from right to left. So the next is UW and UW prime. This was all experimentation. Nothing yet. But if I have R prime and then R, now things are starting to look interesting. When they're mixed colors like this, then some things start happening here. Okay. The next move I do is UW prime and then UW. And it gives me this. Still not seeing it yet, but we're going to see it come together soon. R, didn't work, UW, and then UW prime. Still nothing yet, but maybe what I wanted to do is I wanted to break this up now. That center, so R prime with R. Interesting. There's only 4 discolored centers, and so there are 2 here and 1 there and 1 there. They're all in view. The next move is UW prime and then UW. Now all of a sudden we have an opposite case here. That is 56 moves. Very nice. I guess if I just continue to conjugate just a few more moves. You see, because I just need to get this to the opposite side of the cube with the UW move twice, so that with a final R2 move I make a single dedge flip, and the centers are not discolored, and these two are switched with each other right here in this 1x2 center block. We've never seen this before with the previous algorithms, and same holds true here. So I'm free to conjugate that, and it's not going to affect them being discolored or not discolored. And then it's in the back face here. If I invert all of these moves like I did before in the previous video, I can move it to the front and this is what we have. As of right now, it's 62 moves, and clearly only one move is going to cancel here. This R2 and this R prime is going to become an R, but there's no other move cancellation, so clearly it is 61 moves. But this is pretty straightforward, although quite long.